Hello dear students, once again I welcome all the standard 10 students on this online classes. So I hope all of you are doing that section exercises question answer which are given in page number 36. Yes, already we have discussed 20 number of questions. It will be a hint for you whatever we are discussing, yes, so that based on that hints you will try to solve the question answer, yes. But no doubt in the next class, that means whenever I will take, next class means whenever I will take your online class, that means online live class, at that time on the blackboard also I will clarify your doubt, okay. So now whatever we will be discussing, that one will be a hints for you, okay, so that you can try to solve that one by your own, okay. So already 20 number of questions we have discussed. So today we will start 21 onwards. Some of the questions only we will be discussing, okay. So let's start. A small plane with a mass of 1500 kilogram climbs to a height of 1.8 kilometer in 8 minutes, where it levels out in straight levels and flight at 180 kilometer per hour. Taking g is equal to 9.8 meter per second square, calculate its potential energy and kinetic energy, okay. So here first we have to look at the given things. What are the given things? Simply we have to write the given things. And one more thing also we have to check whether it is given in the SI system or not given. If it is not given in SI system, then it is better to convert that one to SI system. After that only we can solve, okay. So a small plane with a mass is given, that is 1500 kilogram is the SI unit, so no need to change it. Then climbs to a height is given 1.8 kilometer, but kilometer is not the SI unit of height, meter is the SI unit of height. So 1.8 kilometer is equal to 1800 meter, yes. Then time t is equal to given 8 minutes is equal to 480 second, okay, where it levels out in straight levels and flight at 180 kilometer per hour. That velocity is also given, but it is not given in SI system, so we need to convert that one to meter per second. So after converting that one 50 meter per second, it will come, taking the value of g 9.8 meter per second square. Now it is the time to calculate the potential energy, and you all know that one potential energy is equal to m into g into h. Everything is given, just simply we have to put the values in the given equations or formula, so that we will get the answer. Sometimes the question will be coming or the decimal point will be different, so to arrange that one accordingly we can change the decimal point, decimal place also, yes. So in that way the answer will be coming. So don't worry about that one. Maybe you will be thinking that sometimes the answer is not coming, but here it is given like this 264600, like that it will come, but we can change it 2.67646 into 10 to the power 7. We can make it also by changing its decimal point, okay. Then the next one, kinetic energy is equal to half mv square. Yes, mass is given, velocity is also given, simply just we have to put the formulas, put the values in the formula and we will get the answer, okay. Then number 22, a fully loaded elevator car has total mass of 1950 kilogram. If it rises 24 floors, a distance of 96 meter in 15 seconds, calculate the potential energy of the car. Take g is equal to 10 meter per second square. See, if it rises 24 floors, just to confuse the students, it is given that 24 floors. There is no use of this 24 floors, okay, because the distance also after that it is given a distance of 96 meter in 15 seconds. Calculate the potential energy, yes. So how can we calculate that one? Potential energy is equal to mgh, mass is given 1950 into that acceleration due to gravity 10 we can take, yes, into h height, that is 96. It will come 1.872 into 10 to the power 6 joule. Okay, simple one only. Then 23 number, a body of mass 5 kilogram is projected up a broad inclined plane at 30 degree. Okay, see here, this question, it will be difficult for all of you to understand through this way. So specially 23 number, I will be solving that one on the blackboard. Okay, so just I am explaining that one. A body of mass 5 kilogram is projected up a broad inclined plane at 30 degree. One inclined plane is there which is having a 30 degree angle with the horizontal. Yes, with an initial velocity of 6 meter per second. Okay, 5 kilogram mass is there and one inclined plane is there. That 5 kilogram mass object is projected up a broad inclined plane at 30 degree with an initial velocity u is equal to 6 meter per second. If the frictional force opposing its motions is 4.5 Newton, obviously one slope will be there from the ground to the slope. If we are traveling, then obviously the frictional force will be there. Yes, and that frictional force is given here 4.5 Newton. That is the opposing its motions is 4.5 Newton. Find the distance it travels before coming to rest and its increase in potential energy at the end of the run. Okay, so let's start this one. U is equal to given how much, that is 6 meter per second. Then V, because find the distance it travel before coming to rest, that means the final velocity becomes 0 only. Yes, and m is equal to 5 kilogram, it is given. Okay, then from Newton's second law, net force acting on it is equal to how much it will be, mg sin 30 degree plus frictional force. Yes, so F net is equal to mass into accelerations, then mg sin 30 degree plus frictional force is there. So mass into accelerations, 5 into a accelerations will be. Okay, then mg sin 30 degree, the value of sin 30 degree is equal to 1 by 2 only. Yes, the value of g is 10 only and mass is given 5 kilogram only, plus the frictional force is given 4.5. So from that only we can calculate the accelerations a is equal to 6 meter per second square, it will come fast. Okay, now after finding out that accelerations 6 meter per second square, we can use that equations of motion, that is b square is equal to u square plus 2as. Okay, so in that case we can calculate the displacement. Okay, that is minus 3 meter it will come. Okay, minus 3 meter it will come, but it is given here 3.1 meter it is given, but minus 3 meter it will come. Okay, then what we have to do, from law of conservations of energy we know that change in potential energy is equal to change in kinetic energy plus work done by friction. Change in the potential energy is equal to change in the kinetic energy plus work done by the friction only, because of the previously it was having potential energy, but while it is moving, okay, in upward directions or through the slope, at the time that potential energy get converted into kinetic energy. At the same time it has to overcome that frictional force also. So obviously that work done by the friction also we need to include. So change in potential energy is equal to change in kinetic energy plus work done by the friction. Now separately we have to calculate that one, change in the potential energy is equal to change in kinetic energy is how much, half m b square minus u square. Yes, so here u square minus 0 square we can take here, because the final velocity is equal to 0 only, plus frictional force into s, that is fs cos 180 degree. Okay, because horizontally it will be traveling after some times. Yes, that one will be there. I will draw that one on the blackboard so that you can understand properly. After that only I will explain. Okay, so just this one is a hint for you. Then del u can be written as that means the change in potential energy can be written as del u is equal to half into mass 5 into 6 square it will come, plus frictional force F is equal to 4.5 into the displacement already we have calculated, that is 3 into cos 180 degree is equal to minus 1. So, after solving that one we will get 76.5 joule, okay, 76.5 joule it will come. So, we can round up that one also and write, okay. Then the next question number 24. A ball of mass 1 kilogram is dropped from a height of 7 meter and rebounds to a height of 4.5 meter. Calculate its kinetic energy before the impact, that means before striking the ground, and its initial rebound velocity after rebounding, that means after striking the ground, when it will rebound to the space again, at that time what was the initial velocity, at the same time the kinetic energy, then the loss of kinetic energy also we need to calculate, okay. So, mass is given 1 kilogram and height is 7 meter, yes, and kinetic energy at a particular point when it was moving downward direction at that time is equal to the potential energy at the previous point, okay. So, a ball of mass 1 kilogram is dropped from a height of 7 meter, that means previously it was rest on a particular height, that is 7 meter height, yes. So, how much amount of kinetic energy it will gain? Obviously, previously how much amount of potential energy gained by it, that much amount of kinetic energy only it will be attained, yes or no. So, here we can calculate that one as kinetic energy at particular point is equal to potential energy at that particular point only. So, mgh1 we can calculate, mass is 1 kilogram, 1 into 10 into 7 is equal to 70 joule it will come. Then kinetic energy at B, that means a particular point when it strikes the ground at that time, whole of the kinetic energy get converted into potential energy, yes or no. That is, see, kinetic energy at a particular point when it strike on the ground at that time is equal to the potential energy at C, that means after rebounding it will reach up to a certain height. If we will consider 3 points, A is the starting point, B is the point on the ground where it strikes, and after rebounding C is another point, yes. This one also I will draw on the blackboard and I will make you understand so that it will be easy for you to understand, okay. So, kinetic energy at the ground is equal to potential energy at the particular height is equal to mgs2. So, in that way also we can calculate 1 into 10 into 4.5, yes, is equal to 45 joule only it will come. Let the rebound velocity be v2 after impact, yes, rebound velocity be v2 after impact. So, we have what we have to calculate? The loss of kinetic energy, yes, the loss of kinetic energy. So, let the rebound velocity be v2 after impact. So, half mv2 square is equal to mgh2, okay. It will be difficult for you now. I will we just leave this question and on the blackboard only I will explain this one, okay. But the answer will come. Sometimes it is confusing also, your questions it will try to confuse you, and sometimes it is not related to the book also. That means that part or that portion is given in the higher classes, that type of questions are also given somewhere, okay. So, it is better I will solve it on the blackboard, that one, okay. Then loss in the kinetic energy, how can we calculate? Yes, mgh1 minus mgh2, the previous kinetic energy minus the final kinetic energy, or we can say that one, that final kinetic energy minus the previous one. We can calculate that loss of kinetic energy also, okay. Then number 25, a car of mass 1000 kilogram travelling at 90 km per hour is brought to rest by brakes in 100 meter. This one is quite simple one, okay. You must try this. Initial kinetic energy we have to calculate, then the average braking force is equal to mass into acceleration. Mass is given A we need to calculate, yes, by using the equations of motions, yes, and we can calculate the force also, that is force is equal to mass into acceleration. Here in negative only it will come because retardation is taking place, yes, because brakes are applied means the motions will be decreasing. So you must try this one. Then number 26, a car is moving with a velocity of 36 km per hour. Express this velocity in meter per second. See, express this velocity in meter per second means very simple one. Simply just we have to multiply 5 by 18, it will come 10 meter per second. Okay. Then what we have to find out? What velocity will double its kinetic energy? So let's take the kinetic energy is equal to half mv square. Let for the velocity u the kinetic energy double. So half mu square is equal to 2 into half mv square also we can write. That is the double kinetic energy. Yes. Then u square is equal to 2v square it will come. Then u is equal to root 2v. Then u is equal to the value of root 2 is 1.414 into the velocity v is equal to 10, it will come 14.14 meter per second. Okay. So up to this much you must try that one. Okay. Number that 24 and 23 specially, I will explain that one, don't worry about it. Okay. So up to this much you must try it properly. Okay. Thank you.